This is Weekend Academy. Today now we are going to see Brewster's law in physics. By nature, an ordinary ray of light oscillates in all planes in the direction of propagation. This is said to be unpolarized light. A ray of light is always oscillating in all planes in the direction of propagation. So such ray is said to be, again we call it as unpolarized ray of light. There is another one is called plane polarized light. If the rays oscillate in only one plane, it is called plane polarized light. A plane polarized light, one which oscillates only in one plane. See, this oscillates only in one plane like this. But whereas this one oscillates in all planes like this. So this here, and say. Okay. So when such unpolarized beam of light incident on a glass surface like this, there occurs two things. One, a part of the incident ray get reflected back into the same medium, and a part of the incident ray refracted into the glass, the second medium. It happens. So here, one more interesting thing, the reflector ray is partly polarized. Now we have seen, unpolarized light, polarized light. Incident ray is unpolarized light, but the reflector ray is partly polarized. The degree of polarization of the reflector light depends upon the angle of incident. This is called angle of incident I. Okay, it's depending upon the angle of incident. Now, when the angle of incident is, see, this angle of incident is say 0. When the angle of incident is 0, what happens? The ray simply vertically, it is simply vertically fall, simply passing through. The ray, the angle of incident I is equal to 0. In that case, incident ray is at normal and it passes through simply into the second medium and no reflection occur. The incident ray is unpolarized and refractor ray also unpolarized because no polarization taking place when the angle of incident is 0. Suppose the I is slightly more, then only, as I said earlier, a part of the incident ray reflected back and another part of the incident ray refracted into the second medium. The reflector ray partly polarized. This amount of polarization or degree of polarization depends upon the angle of incident, I said. So, for a particular value of angle of incident, I say again, for a particular value of angle of incident, what happens? The reflector ray is completely polarized, and this I is called polarizing angle IP. Now we call it IP. So when the angle of incident is equal to IP, the reflector ray is completely polarized. This happens for a particular value of angle of incident. Okay, and that is called polarizing angle IP. And here we see one more interesting thing. The reflector ray and the refractor ray both are mutually perpendicular to each other. In other words, the angle between them is 90 degree. Understand? When the angle of incident IP, angle of incident I is equal to IP, what happens there? The reflected beam is completely polarized and the reflected ray is perpendicular to the refractor ray. Refractor ray is partly polarized. Okay, now see this normal is a vertical straight line. This angle is 90 degree and this is IP. What is this? Reflector, angle of reflection. This is IP. IP plus R equal to 90 degree. IP plus R equal to 90 degree. Okay, then R equal to 90 minus IP. Now we know refractive index nu is equal to sin IP by sin R. In the place of R, we can write 90 minus IP. When you write 90 minus IP, we get to know sin 90 minus IP equal to cos IP. Therefore, nu is equal to sin IP by cos IP, which is equal to tan IP. So the relation between the refractive index of the second medium and the angle of polarization IP is given as tan IP equal to nu, refractive index. This relationship is called Brewster's law. Okay, this law gives the relation between the angle of polarization and the refractive index of the second medium. Okay, this is all about the Brewster's law. By using this law, device called polarizer is constructed. A polarizer, a device which produces a plane polarized light from unpolarized glass source. It works on the principle of Brewster's law. Okay, where and all we use this polarizer, we use in day-to-day life as a sunglass. We have, you have heard of the word, sunglass, which reduces the glare. Then even in photography as a filter, it is used to improve the quality of photography photos. And also we have come across the word LCD. What is LCD? Liquid crystal display monitor. Okay, this LCD display purely depend upon polarizer. It is nothing but liquid crystals are sandwiched between polarizers, and it is said to be liquid crystal display. We know this, and also many more fields like medical devices and etc. We are using the concept of Brewster's law, the principle. Okay, to sum up from the beginning, Brewster's law. First, we have to know what is unpolarized light. It can oscillate in all the possible planes. What is a plane polarized light? It oscillates only in the one plane. When a beam of light incident on a glass surface, a part of the light is reflected and a part of the light is refracted. The reflected ray partly polarized. It's the degree of polarization depends upon the angle of incidence. The angle of incidence is 0, then the ray vertically fall into the glass and it passes through, no reflection. The incident ray and reflected ray both are at one line and it is unpolarized. When angle of incidence I is slightly more than the 0, then the phenomenon of reflection and refraction both occur. The part of the light reflected back is partly polarized. The amount of polarization depends upon the angle of incidence. Suppose the angle of incidence reaches a particular value, that is IP, then the reflector ray is completely polarized. Okay, this angle is called angle of polarization or polarization angle IP. Okay, and this otherwise called Brewster's angle. See this picture, this is straight line normal here, and reflector ray and refractor ray at this condition are at 90 degree, and therefore IP and the refracted angle R together is 90 degree. R equal to 90 minus IP. And now we know the refractive index of this medium nu is equal to sin I by sin R. The R is nothing but here 90 minus IP. So sin IP by sin 90 minus IP is called cos IP. This comes to know nu is equal to sin IP by cos IP, which is equal to tan IP, and this relationship is called Brewster's law. Using this Brewster's law, devices called polarizers are made. These polarizers are used in day-to-day life in many places. That's all about the Brewster's law. In another video, we will meet again with some more important topic. Thank you.